Hello everyone, welcome to my channel. My name is Said Ali Abbas and today we are going to discuss about ordinary differential equation. In this video we are going to discuss how we can formulate a differential equation from a given relation, and we are also going to discuss the solution that a differential equation has. So this is basically our lecture number 2. In lecture number 1 we have discussed the definition of ordinary and simple differential equation. We have also discussed the order and degree of differential equation, and we have identified some differential equations with their orders and degrees in the last lecture. So this is our lecture number 2. So the purpose of this short course is to provide general and to the point information that is required for understanding differential equation. So this course is basically helpful for those person who just started differential equations and who are not well aware of the basics of differential equation. So we are not going in so much details, so our focus is to provide to the point information regarding differential equations. So let's start. So what we are going to discuss in this lecture: the first is the formation of differential equation, and the second is the types of solution that a differential equation has. So let's start the formation of differential equation. In order to understand it more comfortably and more better way, I am going to solve a particular example here, and this will help us that how we can formulate a differential equation from a given relation. So here it is our question. We are going to form a differential equation from that particular relation. It is quite clear that in this relation, that is y is equal to a sin x plus b cos x, x is basically an independent variable and y is the dependent variable on x. So whenever we are given with some relation, or you may say function or any equation, and we have asked that to form a differential equation out of it, the very first step is that we have to identify the arbitrary constants available in our given relation. You can see that in our given relation there are two basically constants. First is a and the second one is b. So these number of arbitrary constants are very important, as they will tell us the order of differential equation that will form as a result of its differentiation, and I will perform all the steps involved in it here. So the number of constants basically determine the order of differential equation that we will form after solving that particular equation. And the other important point is that the number of constants also tell us that how many times we have to take a derivative of that particular relation. If we are given with two constants, it means we have to derivate it twice. If we are given with three constants, it means we have to derivate it thrice. So the number of constants tell us that how many times we have to differentiate it. So as there are two constants, so we must have to differentiate it twice. So we are going to differentiate it. So if we differentiate that particular relation with respect to x, that is taking derivative on both sides, to the very first equation we will get, that is dy over dx is equal to a cos x. As you know that the derivative of a sin x will be a cos x. A is constant, it will remain the same, and the derivative of sin x is basically cos x. We are just ignoring the derivative of x with respect to x, that is 1. So we are not writing 1 here, as it will have no impact on that a cos x. That is why I have not written 1 here. So now if you take derivative of b cos x, b is constant, b will be same, and the derivative of cos x will be minus sin x, and that minus will turn that positive into minus sign. That is why here we have minus sign, and the derivative of cos x is sin x. So we have differentiated first time, that is we have taken the derivative first time. As we have two constants, so we have to differentiate it again. So differentiating again that particular equation with respect to x, now we have a second derivative, that is why 2 is appearing on above 2. So the derivative of a cos x will be minus a sin x, and the derivative of b sin x will be b cos x. So now you can see, as we have two constants and we have completed differentiating it twice, now we have to like solve in a way that this y get involved in that particular equation. And another way you may say that the number of equation, number of constants in a relation determines that how many times you have to take derivative, plus if there are two constants, it means you have to form 2 plus 1 means 3 equation in order to eliminate that a and b terms completely. So what we are going to do, you can see that minus is appearing with a and b, so I am going to take that minus common. So after taking minus common, our final equation will look like this. And in this, a sin x plus b cos x is very clear that it is equal to y. So we will substitute a sin x plus b cos x equal to y here. So substituting the value of y from the equation, that is the equation we are given with, we will get that. And this minus y on moving towards the left hand side will become d square y over dx square plus y is equal to 0. So this is our required differential equation. So we have completed the task of forming the differential equation from given relation. So the very important point is that I have told when we are starting to differentiate this particular relation, that the number of constants involved in your relation will determine the order of your differential equation. So you can see that now that a and b are basically 2 in number, that is we have 2 constant here, and the order of differential equation that we got from that particular relation is also 2. And why I have written general solution beside y is equal to a sin x plus b cos x, because this particular relation is called a general solution. So I am going to discuss in the next slide that what is a general solution. For instance, you have to keep in your mind that y is equal to a sin x plus b cos x is the general solution. Why it is called general solution? Because it contains some arbitrary constants, and when you assign some if you assign a and b constant some particular value, this general solution will become a particular solution. So in differential equation, that particular relation that is free from any derivatives is called general solution, and this general solution will satisfy its differential equation. That means if you substitute that y is equal to a sin x plus b cos x in that particular differential equation, it will satisfy that differential equation. So these are the important points that I have told, and I think you are clear with that how you can form a differential equation from a given relation. You just have to keep in mind the number of constant appearing that particular equation, and you have to take derivative that much times that is equal to the number of constants. If it is 2, then you have to differentiate twice. If the constants are 3, then you have to differentiate it thrice. So now moving towards the types of solution. So the important points that I have told earlier, I'm going to repeat it again so that you remember. The very first point is that every solution satisfies its differential equation. So as y is equal to a sin x plus b cos x is our general solution, and I told you earlier that it will satisfy the differential equation formed after it, that is its own differential equation. It will always satisfy that differential equation. Second, the order of differential equation formed will be equal to the number of arbitrary constants in the provided equation. As you have seen that the order of differential equation is equal to the number of constants appearing in the general solution. So the order of differential equation will always be equal to the number of arbitrary constants available in the given relation or equation. And in the last, I'm going to discuss the solution. So solutions of differential equations are of basically 2 types. One solution is called general or complete solution, and the other one is called a particular solution. So the types of solution of differential equation, and this solution is quite clear. A solution is basically a relation which is free from any derivatives, and it will satisfy the differential equation that is formed after differentiating that particular relation. And I have solved an example in front of you, and it is quite clear the definition for the solution of a differential equation. Further, I can read that a solution of a differential equation is a relation between the variables not containing derivatives. So the general solution don't have any derivative, as you have seen that y is equal to a sin x plus cos x, the example we have done, don't have any derivatives involved in that. That is why it is called general solution, such that this relation and the derivatives obtained from it satisfy the differential equation. And I have told you that the relation will satisfy the differential equation of second order that we have formed in the end. So this is the necessary part to be the solution of a differential equation. So there are basically 2 types of solution. One is the general or complete solution, and second one is the particular solution. So so far their definitions are concerned. What is basically a general solution? So general solution of a differential equation which contains as many arbitrary constants as the order of equation. So you have seen should have to write it that you have seen our example, that is y is equal to a sine x plus b cos x. Let's take that example again. So here a and b are arbitrary constants, and they are arbitrary constant, and this particular relation is called general solution. So if you have a differential equation, general solution of differential equation means that an equation that have some arbitrary constants, like we have that a and b here as arbitrary constants. So if you assign that particular constants a and b some value, then it will become a particular solution. So a particular solution of a differential equation is obtained by giving particular values to constants. So if we assign that particular value a some value, and we assign some this b some value, then it will become a particular solution. So this sums up the today's presentation. So I hope you understood it all. So thank you so much for being here.